Hi, I'm Tim Shotney. In previous lesson we built a simple monophonic synthesizer as Max4Live device, and now I want to improve it by changing its synthesis algorithm. Here in my Ableton session you can see this synthesizer, and we can trigger it with this MIDI clip. We can change all these parameters for its amplitude envelope. This is ADSR, you can change sustain, release, anything. There are all parameters which you might want to have. And although we have such a great control over the amplitude of sound itself is quite simple and can be boring, because it's a sinusoidal oscillator. And of course sinusoidal oscillators are great, but sometimes you want something else. And that's what we would do right now. We would modify this synthesis algorithm by removing this sinusoidal oscillator and adding something else here. And this would be a simple FM abstraction. You can see that it looks like an object, but when we lock the patcher and double click on it, there's actually a patch inside. And when you think that this is an object but you double click on it and you get a patch, this thing is called an abstraction. So we have this simple FM abstraction which gives for us an oscillator with frequency modulation possibility. So down there you can see there's a cycle oscillator, which is a sinusoidal oscillator, and we have possibility here to frequency modulate it by another sinusoidal oscillator. And there are three inputs. The first one is for carrier frequency, another one for harmonicity ratio, and third one is modulation index. So basically how much of frequency modulation we would have. And all these three inputs are expected to be as signals. So the first actually input we could directly connect with this number. So the frequency which we get from our MIDI. But as I told, we need to convert it to signals. So there's an object for it which is called sig tilde, converts numbers into audio signals. Now we can create two other controls for harmonicity ratio and modulation index. So I would use a simple live dial. And for harmonicity ratio, I would like to make our live dial a little bit different. First of all, I would change its range from 0.25 to 5 and make its unit style float. Perfect. Also rename it like this. It's quite a long name. All right. I think it's not so bad. And then I also convert its output to signal. And then I would copy this harmonicity control and change now for the second one range to 0 to 1 and rename it to modulation amount, so just mod amount. And this one I would send to the third input. And I just add these two controls to presentation mode. I made it now with combination which is Shift-Command-P. And then the output of simple FM I sent to the multiplication object. So let's listen if it works. Also let's place these two parameters here. Harmonicity and mod amount. And let's listen. It really works. So when modulation amount completely down and it's equal to 0, then we have still sinusoid, and when it goes up, then we get more and more this frequency modulation effect. And harmonicity, of course, creates different proportions between the oscillator which is modulated by frequency and oscillator which modulates its frequency. Cool. So I won't explain in details how frequency modulation works here, but that you just know, frequency modulation is very similar to how amplitude modulation works. And you can look up another video from this course where I explain how amplitude modulation works. But to explain it briefly, it's like an amplitude modulation, but you create those sideband frequencies for all integer multiples of modulator frequency. So basically, what I mean by that is just we imagine that we have a carrier frequency here equal to 500, for example. And the frequency of modulator, which we get here, somehow is, let's say, 100. Then we will get sidebands on the first multiple integer of this frequency, which is just 1. So 100 multiplied by 1 is 100. And then we add and subtract from 500, 100. It means we get first pair of sidebands at frequencies of 400 and 600. Then the next pair of sidebands would appear on, so 500 minus 200, 500 plus 300, which means 300 and 700, and so on. That's why on the spectrum you can see that like from one frequency we get this kind of sidebands going more and more on sides, like there's some castle from Lord of the Rings, some Sauron tower grows from the ground. So I just show you what I mean. On the spectroscope, spectrum, let's quickly close it, and then let's just make one node which is sustained. And then I increase mod amount. Let's make harmonicity something like that, and then you can see that we get this castle growing. And if I go to higher frequency, it might look more clear. That's briefly how frequency modulation works. And we could also create, for example, envelope for our modulation amount. So we could just copy these two things and just also send from this comparison object output to our live.adsr input and use its output, for example, for modulation amount. So we could delete this modulation amount control and control it with this ADSR. Because it's perfectly also going between 0 and 1. Let's just also place it somewhere here, save it, and then I want to create again this sequence quickly, then here, and the last one maybe here. Now we get these kind of wooden sounds. And of course, such synthesizer makes much more fun to play with. And then you can modify all these things. You can also add this all controls to this ADSR, which controls the modulation amount and also modulate and automate in Ableton and so on. So this is creative work for you, and thank you for watching, and we will see us in the next video where we would create from this monophonic synthesizer a polyphonic synthesizer. So see us next time, and bye bye.